Welcome back. In the earlier lesson, we have discussed that there are two types of symmetric encryption methods, DES and AES. DES is the old encryption standard encryption methods, and AES is a new modern symmetric encryption methods. So in this lesson, we're going to discuss the processes that are involved in AES. There are four types of AES, depending on how multiple blocks of the plaintext and ciphertext are encrypted and decrypted. In this course, we will only be discussing the first two types, ECB, electronic code book, and CBC, cipher blockchaining. The other two types, CFB and OFB, will not be covered in this course. AES in ECB mode. Assume that you are the sender who wants to send a secret confidential message, P, to a recipient. So you have to encrypt the message so that it has the confidentiality property. So this process can be denoted by this mathematic notation. Ciphertext C is the outcome of the function E, which takes as input the plaintext P and the key K. So the first step that is involved in the encryption process is to convert the plaintext P into its equivalent binary string, because computer can only understand 1010 language. It cannot understand any other language. Now, the binary string is then partitioned into multiple blocks of 1 to 8 bits, assuming that we are using the key K, which has a size of 1 to 8 bits. What I mean is that if you are using a different key size, for example, 192 bits or 256 bits, you need to partition into multiple blocks of corresponding sizes. But in this example, I'm assuming that the key K has 1 to 8 bit size. Next, the secret key K is then used to encrypt the first block, resulting block P1, which will produce the first ciphertext block C1. And this encryption will also ensure that the resulting ciphertext block C1 has the same size as that of the key K. Of course, same as the block P1. Subsequently, the same key is then used to encrypt the rest of the ciphertext blocks to the rest of the plaintext block to produce the rest of the ciphertext block C2, C3, C4, and so on. So that is the encryption process involved in ECB mode. Now, assume that the recipient has received the ciphertext message, which is a concatenation of C1, C2, C3 blocks, which is basically a binary string. So now the very first step involved in decryption is to partition it back into the multiple blocks, which has the same size as that of the key K again, just like what we did in the encryption process. Next, the same secret key K is then used to decrypt the very first block C1, which will produce the original plaintext block P1. And subsequently, the same key is then used to decrypt the remaining ciphertext blocks C2, C3, C4, and so on, which will produce the plaintext blocks P2, P3, and so on. And all of them will have the sizes that is the same as the key K. So in the final step, we need to convert the resulting plaintext P1, P2, P3, P4, and so on blocks into the appropriate data format to get back the original plaintext message. And this data format is some kind of format that the human user can understand. Now, let me give you a more concrete example to illustrate things much clearer. But one very important thing to take note here is that this is a simple a try example in which we will be using XOR operation as the encryption and decryption function. This is because I simply cannot afford to use the actual encryption method used in AES because, as I told you before, it is a way more complex system. So instead of that, I can only be using XOR as the encryption and decryption function, but this will serve the purpose. This will clearly illustrate how AES in ECB mode work. And if you do not have prior knowledge about how XOR operation work, please refer to the YouTube link that I have shared with you earlier, or you can discuss with me offline. And this is the Boolean truth table that represents the XOR, bitwise XOR operation. And I will be using this symbol to denote the XOR operation. So now, assume that you are given a plain text P, which is a confidential message, A, B, and A, and you have selected a key K, which is a backtick character, to encrypt this plain text message. So firstly, the first step that is involved is to convert this into the binary string format so that the computer can understand it, right? So let me go to this web page, which is ASCII-table.com, which provides the ASCII character to its equivalent decimal value conversion. So here, one of the very first character of the message is A, which is equivalent to the decimal value 97. The next character B is equivalent to the decimal value 98. And the last character is also character A, so it is the same as before. And the key K character is a backtick character, which is this one actually. It is equal to this decimal value 96. So once you obtain those equivalent decimal value, you can convert them into the equivalent binary string format by using this binary conversion table here. And you will get the binary strings like this. And again, if you have no prior knowledge about how to convert a given decimal value into the equivalent binary value, please discuss with me or refer to the YouTube video that I have shared with you earlier. So you end up with the plain text message ABA, which is in this binary string format. And it has the size of 21 bits. Each character, ASCII character, has 7 bits. And since you have 3 characters, it will be 21 bits. And the key K, the backtick character, has this binary string, which is the size of 7 bits. So again here, of course, the standard size of the key K used in AES is 128 bits or 192 or 256 bits, but I cannot simply use this 128 bits here. It will be too much to handle. So I'm just using a 7-bit size to illustrate things. So if you break it down, the given plaintext P into the multiple blocks, each having 7-bit size, you're going to end up with P1, which is this one, and you're going to end up with P2, and you're going to end up with P3. And all of them, each of them has 7-bit size, which is the same as the size of the KK here. And next, we need to encrypt the plaintext message. And here, the encryption function that we're using is XOR function, as I told you before. So we apply the XOR operation as the encryption, taking the input P1 and the key K. And this is replacing this variable with the actual binary value. And if you do the math, the XOR operation, here, as shown here on the top right corner, this is the value that you get. And just like that, you can do the same process to encrypt the plaintext P2 and plaintext P3, and this is the result that you will get. You can do the math on your own, okay? And all of these are applying XOR function as the encryption. So now, once you get those ciphertext blocks, C1, C2, and C3, you just simply need to concatenate them. So this is a concatenation symbol that I'm using, okay? So this is a concatenation operation. Once you concatenate them all, it is simply just concatenate C1 with C2 with C3, and overall string is a binary string, which is denoted as C, ciphertext. And that is the encryption process with AES in ECB mode. So now, assume that this ciphertext was received by the recipient, and he needs to decrypt so that he can read the original message, plain text. And the assumption is that the recipient also have the same key value K. Remember that when we are using the symmetric encryption, both the sender and the receiver must have the same key K. They must use the same key K to encrypt the message and must use the same key K to decrypt the message. And that's why it is called symmetric encryption. So first step, again, same thing. We break down the given ciphertext into the 7-bit size each, which is the same as the size of the key K. And each block is being decrypted by using this XOR operation again. The first cipher block, C1, apply XOR operation by using the key K. And if you do the math, you get this result. And likewise for the ciphertext C2, and likewise for the ciphertext C3. So finally, you simply need to concatenate the resulting blocks, plain text block, P1, P2, P3, and so on, to get the whole plain text string here. And finally, simply need to refer to the ASCII table to get back the original ASCII character. So this first block is equivalent to character A, second block is equivalent to character B, and the last block is equivalent to the character A, which is the same as the original message, ABA. So this is the process steps that are involved in the decryption process. And if you have understood, try to do this exercise, encrypt and decrypt a given plaintext P, which is hello, by using the key K, which has a value of the character Z. In the next lesson, we will discuss about whether this AES-ECB method is secure, and obviously the answer will be insecure. That's why we are having other encryption modes in AES, and we will discuss why it is not secure and what is the solution to address this problem. Thank you very much. See you next time.